Hi everyone, welcome back. And in the previous video, we talked about the while and do while loops. Just a refresher: the while loops and do while loops are all um, like repetitive blocks of code. They are meant to repeat the same block of code over and over. And typically, if you want to iterate over the elements of an array, or you want to do some more like for example here you are just counting you're counting all the scores from the user input. In those cases you use the while and do while blocks. Okay, so now we are going to study about the for loop. The for loops typical use case is just like that. You write uh, let me start projecting the screen. So a typical for loop simply looks like this. You have the initialization expression, then you have the Boolean expression, then you have increment expression. So what does that mean? So think about a situation that you want to iterate over the numbers 1 to 10. Okay? Suppose there is a very simple programming problem given to you, that is they asked you to create a program that will iterate over the natural numbers from 1 to 10, all the natural integer numbers. So basically your task will be just iterate over 1, 2, 3, all the way to 10, right? And for each iteration, when you come to 1, you just write the number 1. I mean, the number is 1. Then you write the number is 2. Then you write the number is 3, and so on until it reaches the number is 10. So that's our use case. And you know, in that case, this problem can be solved by introducing a for loop. I know that this problem could be solved by the while and do while loops, but we can solve the same problem using the for loop as well. So the typical situation with the for loop will be for, and then you write the initialization criteria. That is, you need to have an index. So you write integer I equals 1. So you remember your number starts from 1. Then you put a semicolon. This is the syntax of the for loop. Then you write the Boolean condition. So long as I is less than equals 10, you should go on. And then another semicolon, and then you increment I. Either you do I plus plus or you do plus plus I, doesn't matter. So within the curly brace that designates the block, so you can write cout, that is your output statement. Then you write I is the variable that you are trying to display between 1 to 10, and you write an end line, endl, so that there will be a new line and you are going to write that number. So that is the basic syntax of the for loop. So you can see here that this is the initialization expression, right? Then this one, I less than equals 10, this is the Boolean expression. And then I plus plus, this is the increment expression for the for loop. Okay, why don't we write a program on that? Let's see. Let's write a program on for loop. So it can be as simple as you can write, let me get rid of this. Let's write for integer I equals 1, I less than equals 10. I plus plus. As I explained, we are writing the same thing, and then we can write cout I end line. Okay, this is our for loop. So notice the syntax. You are writing I equals 1, this is the initialization. Then you write I less than equals 10, that is your Boolean condition. So long as this condition is true, this loop will run. Then you have I plus plus, which is the increment operation on this index, which was initialized. Okay, and then within the loop, you are doing your programming work. In this case, it is just writing a cout. Always remember that whenever you write a for loop, it is the best practice that you should put the code block that is required to be executed within the for loop. You include those with you wrap those up by curly braces. If you don't do that, then there will be problem. There won't be any compilation error. But if you have more than one lines of code to be executed iteratively, then you know in that case there will be a problem, that is your first line will be considered, but all subsequent lines won't be part of the for loop. Okay, so I mean if you don't put a curly brace, then that will become an inline for loop. So you start the for loop and then you put some statement and then you put a semicolon that will end the entire command. So there won't be anything related to the for loop afterwards. So make sure when you use a for loop, whether or not you are using more than one line, I mean, it doesn't matter. I mean, I'm telling you as a best practice, not that your compiler will create some problem, but it doesn't matter what kind of block you are using, always try to use a curly brace. That is the best practice. So if you run this for loop, then, I mean, this code, then you will end up with this result. So you can see that this code is printing the numbers from 1 to 10. So that's pretty much a simple illustration of the for loop. Okay. Now we talked about the loop without the braces. I told you that avoid writing any loop without the braces. Now you can have another example, a for loop that adds the numbers, several numbers, let us say. So numbers 8, 6, 4, and 2. So in that case, the problem will be, I mean, it's not increment operator anymore, rather than it will be a decrement operator. But the decrement is not like I minus minus, because you have a step, like there is a step of 2. See here? So typically, your loop would start with I equals 8, that is your first number. The second number is 6, that means 8 minus 2 equals 6, 6 minus 2 equals 4, 4 minus 2 equals 2. So you are basically doing I greater than equals 0, and then um, I mean I greater than 0, or you can say I greater than equals 2 as well. And then you can do I minus equals 2. So that's your typical syntax of the for loop. Let's try this code on Visual Studio as well. So in this case, you can start with, so what we are going to do, we are going to sum up the numbers 8, 6, 4, and 2. So let's start our loop with 8. So let's say I equals 8 and I must be greater than equals 2, right? Because that's the last number. And then you can do simply I, so you can use the compound operator, minus equals 2. So in each step I is decremented by 2. So what we learn from this particular example is that in order that you run a for loop, you don't necessarily need a plus plus operator. I mean, increment by one operator. You can have any kind of step, but the point is the step has to be consistent. I mean, you cannot just plan something uneven. Like you have to add numbers like 1, 5, 12, 16. You cannot do a very consistent for loop out of that. You need additional criteria in order to solve that problem. Just defining a for loop won't solve that problem. So for this one, let's do this. Let's say we do we define a variable called sum, int sum equals 0. Then you can do here sum plus equals I. So at the end you can do cout sum. So if we run this program now, we should receive something like this. It's running. So you get for this loop I equals 0, I greater than equals 10. Sorry, it's not the right thing. It should have I greater than equals 2, I minus equals 2. So you need to do it as follows. Let us clean it up a little bit. So if you run it, you get 20. That means 8 plus 6, 14 plus 4, 18 plus 2, 20. So that's what you get. Final result as 20. Okay, that's how you can do. So what we learned is that um, in order that you implement a for loop, there can be incremental stuff as well as decremental stuff. I mean, it does not have to be always you start with the lower number like I equals 0 or I equals 1 and go to a higher number. You can start with a higher number and step down to 0. Secondly, we learned that your incremental operator or decremental operator uh, can be step can be done in steps. Like you can use the compound operator to accomplish that one, that uniform decrement. And thirdly, if you have ununiform decrement or increment, then you can still run a loop, but you have to impose additional logic to accomplish that type of goal. Okay. So the, referring to the future value calculation, you can see that we can simply use the same for loop for calculating the future value for any investment that we did in the last example. So just, I mean, utilize your previous example for the while loop. Uh, you can use the for loop in this way. Okay. Now comes another interesting feature which is called nested loop. So, so far we have been talking about, a for loop that has only one round of iteration. But there can be for loop within another for loop. That sounds complicated, right? I mean, that's pretty much we are talking about right now. Uh, let's let's say we have a let's say we have a matrix. So the matrix has rows and columns, right? Or you have a table. Tables has rows and column. Now you want to go over the rows and column and find out the elements. How do you do that? So let's say uh, you have rows for the matrix or the table running from 1 to 10 or 0 to 9. You can write a for loop for that. For int I equals 0, I less than 10, I plus plus. That is your rows. Then inside it, you can design a column, and that can be integer j equals 0, j less than 10, maybe it is 10 by 10 table, j plus plus. So if you do that, and then if you print, so let's do it little bit formatted way. It will look beautiful. I, and then you can do comma j. So if you do the end line, now you can run it, run the program. That's not good. So you have, it should be j, not I. So now if you do that, you will find it like this. See here, you started with 0 0, you write the 0 1. So basically for the first row, 0th row, you are writing all the columns 1 2 3 and all the way to 9. Then your second row starts, that is the 1, then all the columns 0 to 9. Third row starts, third row is 2, and then you have all the columns and so on. Okay, so that's how you can build a 10 by 10 matrix. So this is an example of the nested loop. So you have one for loop within another for loop. This situation is called a nested loop. Now, uh, in order that you calculate everything, that means you are going over the inner for loop first, then you go over the outer for loop. That's how the nested for loop works. So what happens if you want to exit the loop? It's very simple. You just put a break statement. So how it is possible? Let's I mean, there are example in here, but let's make up our own example in the code. Let's say we are considering the matrix, but there is a business criteria that after we don't want to they don't want to print, business do not want to print if you're after the row number 5. So it will run up to, although we are running it over 10 rows, but after row number 5, we won't print. How can we solve this problem? So we can simply come here, the outer for loop, and we can say, because it's row, that's why it's outer for loop. So we can say if I equals 4, right? I mean, I equals 5, row number 5 means I equals 4. Then we call it a break. Okay, so when you do the break, it will exit the for loop. Immediately after the break, it will exit the for loop. Let's say we print here what was the latest value of I. So integer k, let's say k is the value, k is the placeholder for I. So we can say that k equals I here, right? Before that, and then we can print just k. So if you do that and if you run the code, you know, you see here it exit, and then the last value of I the loop touched is 4. So the break statement is a way you can go out of the for loop. Okay. Let's move on. That's your break statement. Now there is a continue statement as well. So what does the continue statement means? The continue means it doesn't matter. It can be in the for loop, it can be the while loop, but continue means whatever happens after that within that index, you won't care. It will go to the first line of the for loop. So let's say what happens here. um, if you do, let's say you don't want to print, there is, let's say there is a criteria that you particularly do not want to print j equals 4, that particular row you do not want to print, but you want to print 0 1 2 3 5 6 7 8 9. That means all the rows except the 4. So what you can do here, then you can just write continue. Continue means as soon as 4 is reached. So there is a C out here. So what you should be doing here, this block needs to be here, because as soon as 4 comes here, it will not go below this one. It will just go above at this line, and then it will do as it is. So let's try this code. So if you run, you can see here that you are missing the fourth index, I mean the fifth index, that is 4. It starts with 0. So you have 0, you have 1, you have 2, you have 3. You do not have 4 because you skipped it. By definition, you skipped it, and the way you skipped it is by using the continue keyword. Okay? So you understand the difference between a break and continue, right? When you use a break, you are just exiting out of the for loop. I mean, wherever you are putting the break, that particular for loop. But if you want to do the continue, you are not going out of the for loop. Rather, you are not doing anything that takes place after the continue statement in the for loop, but you are going to the head of the to the starting point of the for loop. Okay, that's the difference between break and continue. These two keywords are very commonly used in the implementations of any business logic in whenever you do programming for software development industry. The break and for loop, they are very effective. I mean, break and continue are very frequently used. So I think that's it. I mean, those are the main elements of the for loop. So we understood in this, I mean, if I consolidate what we have done in the previous video and this video, we focused our discussions on repetitive block of code, and we came across three different ways to implement repetition. One was while loop, the second was do while loop, and third was for loop. Now, you use the for loop if you know exactly what you are doing, means what are the limits. If you don't know the limits properly, then you use either a while loop or a do while loop. Okay, the while loop validates your binary, I mean the Boolean criteria in the very beginning, whereas a do while loop will do the work first and then it will validate the the Boolean condition. So when you implement those, you have to make sure that you understand their implication and you test the code. Okay, testing the code is very important because otherwise you may end up with some um, wrong information. So why don't you go and just write some code that like the future value code, go over that from your textbook and just try to come up with the for loop, while loop, and do while loop. Okay, let me know if you have any questions. Thank you. Talk to you later. Bye.